Bismillah. Well, now I'm talking about the C++ template for Deal 2. I will change the source code and discuss about the C++ template and demonstrate some code, the simple code to understand how on which base the C++ has been built. So, yeah. Uh, it will this video will explain the mathematical notation for mesh, explanation of template of C++ in a certain in a simplest way, and I will explain the mathematical view behind the mesh briefly and represent one of the code. So this video is a reference of this one of the famous professors, Bangert from Texas A&M. Well, I have followed one of his presentation files here and try to figure out the interpretation of his class. Well, this is the template for C++ and C++ tutorial. I will explain the functional and class templates and how to write it, and explain the theory and also explain the code. So what about the basic concept behind it? So since we are working on the quadrature and how to mesh it and what are the mathematical viewpoint behind it, so I have talked about this equation in the previous lecture. So this is actually the uh, yeah this portion is actually related with the phi I to the I-axis, and it's to the Z-axis, and this is for this works as a dx. However, uh, if we want to get the quadrature, then we need to sum it twice. One is for the sum of the cell, that is k, and one is for the quadrature, and q here the q u would be the number of cell. Well, the mathematical notation looks very similar in 2D 1D, but if we um, if we interpret this equation for making the mesh, then this might looks like this one. So I will apply the d-dimensional quadrature formula to integrate on cell k. And first of all, uh, 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 we will, for making the cell, we have to make a for loop on that, like this one. So cell will begin from a certain point and end in a certain point, and it will increase in a for loop. So if it is the d-dimensional way, definitely. So if it turns out the quadrilateral, then it will be considered as 2D, and for 3D it is the example might be the hexahedral. Well, for error indicator, this is one type of equations, and on that we can make the meshes too. So we will make a loop on all cells, and we will make loop for the 6 faces, and d minus 1 is for the loop on the each faces. So yeah, so if I make a loop, then for the edges it will be counted as 2D, and if we apply the loop on the faces, then it will be counted for the 3D. So this is the quite so brief discussion about the making the loop and making the cell. Yep, according to the equations and how we can implement this. So in deal 2, basically there are a lot of templates, so there are a lot of problem defining this type of uh, equations when it's turned into the code. So for example, there might be some variables which are int, or which will be double, which are declared as char. So in that case, uh, we need to write the code base again and again for different variables or different data type. So if we follow the um, template formula of C++, then we need not to declare it again and again. Rather, we can just write a simple code, and within 2 or 3 sections we can get the value without declaring the data type again and again. So what are the advantages for this? Actually, the advantages is, maybe if we want to solve the bug during solving this type of problem, then if there is a bug, we need to uh, solve the bugs in every section. So if we just use the template of a template, then the solving bugs will be in a limited uh, portion, so we can solve it as soon as possible, or conveniently. So I will make the demonstration here. So this is my Linux setup. I will make a file which I will name it as template.cpp, and now I will open it. Well, there are two places where we can apply the templates, such as function templates and the class templates. Now I am going to discuss about function function templates. So templates are the way to write the generic programs, and the main point is we pass data type as a parameter to function or class. So the example, say for example, I will write a code like include for. So this is the very introductory stage of the template, so how it is based on it. So I think it should be done in VS Code, so I am opening it in VS Code. Okay, most convenient. So I will just put here these two numbers, like 19 and y is equal to 100, something like that. Then for output, I will input get maybe and function of getmax, and I will input x, y, and I'll close this one and L, and that's it. So what about the getmax? I have to define it, since I have defined it in int main. So now I will define, since we are dealing with the int, so I am going to declare it first. So the int would be x and int is y, and I have to return it. So for return it, I will make a condition like if x is greater than y, then we will get the x, y, and yeah. Now save it. So this is our function. Let's have a check. For checking it, I will open a terminal here and write g++ template dot cpp o and make an executable file like functions. Yeah, functions.exe. There is some problem here, so I think this one. So I have edited the code here. Just there is some problem, and let's run it again. So g++ template.cpp like that. So there will be created a executive file. So we'll run the executive file like maybe it will work. I'm sorry. .exe. So yeah, here we can see that the y is greater than x, so it is printing the y value. What about I will change it here whether to check it works or not. To check it works or not, and so I will run it like that, and yeah, it's working. So it is 1000. So in this section, if we need to run if you want to consider another data type like the character, if I write it here, maybe some type of character a1 is equal to maybe w, and if I write it here like s, so similarly I need the output here. So yeah, it will not run like this because though it is the function is getMax. So for since there are two different data types, first of all that is int and another one is character, so I have to define it here, the data type. So this is char. Okay, so now yeah, there would be some bucket, and it will be a1 and a2, isn't it? Yeah. So after that we need to, if we want to compare this one, then I have to define the static cast with it. Well, since I have declared this one in the int portion, so I didn't call it here, so I need to declare it here first. So similarly, since it's not int, so I will give it char and the get max of char. Okay, so yeah, there will be also, now it's okay I think, and the function return function is quite like that, but I have to define the char here, So here I have to change it. So if I run it, it will go and run for this int value and this char value. So if there are a lot of data type like float, double, long, like that, then we have to increase this code here again and again. So how to merge all this in one section? This is why we will use the template. Okay, so I will give it a generic form, so that's why we need to give a template. mm, yeah, okay, so I will name the type name, say for example T, and then instead of int I will generalize the x and y with the new defined data type T. So I will put here a T. So now we need to change this one in that case, because I have declared a generic data type. So now for in the int options portion, we have to change this. So why are we changing this? Because we have declared a generic data type, that is T. I can write it here any of the number or word, anything like I want. So yeah, so I don't need to declare now. I don't need to declare the int functions, the character functions or long functions before the int main. Rather, with just defining the template, I can work in here. So there we can just input, say for example the mesh function, the functions for the mesh, function for the cells or elements, or other than that. So let's see whether it works or not. So let's run it. Oh, there would be small t. Let's save it, go to the terminal, delete the previous one, and run this one. Okay, so you can see that it is running. This is the portion of int, and this is the portion of from the char. So we can run it together by using the template, not defining all the data type separately. So this is the functional templates. So how about the class templates? So for class, let's change the function here, just to get maybe another function like add grep, and this it is tx and ty, and what would be the return? The return would be x plus y, sorry. So I will remove this one. Now this is x, y and z. What is the value of the z? So z will be at grep of x comma y. Okay, so we need to print the z here, right? So I think it should work now. Let's get to the terminal. Yeah, it's working. So in this case the answer is 100 and sorry 1100. So what is happening here, if we just add here maybe something like, if we want to change it um, to float, and 0.50, and this would be 78. So what about that? Let's try it. So open a terminal, type this one. Yeah, it's running, so there is no bug maybe. And yeah, this is the answer. So we can get just we need to change the data type here, and this class template is the generalize the generalize the data type whatever we want to. We don't need to add here something like for uh, float, for char character, or for int or something like that. Rather this class of template, this class template can run all of that. So you can get this from my GitHub repositories. However, let's get to the uh, source code here. If you have some problem with running in the Linux, so you can try this website cpp.ch. So you can just run your code here and get the result here. Okay, so let's get to the source code. Well, this is the step 5 for reference. So if we go to here, so they have used the template in dim, and they have used the here, and yep, we have defined the generic template here and run out the cells. Okay, so what about going to Professor Vanguard's PowerPoint? So let's talk about the example here that he mentioned. So if we make a template of indim and triangulation, then we can for the cell formation, actually for cell formation we can make a for loop that I have stated here. Then for loop and it will start from the beginning and will consecutively make cell, and for vertices it will get the geometry info, go to dim, and get parcel. So this is how we can use the template of C++ and gather these two different yeah, so gather these two different type of data set together and run together. You can see here it can be run the cell and the vertex together, and though the data types are different. I am going to mention the reference in the video description. Thank you. So I have demonstrated how to write the template of C++. I have demonstrated a very simple code and also explained the theory for the mesh of an example. So, and the mathematical viewpoint behind making mesh, and also to for having multiple answers we may apply the C yeah, in the C++ we may apply the template function. So this is one of the uh, file. You can see here the step 3. This is one of the basically uh, one kind of that kind of uh, theory has been turned into codes. So I will take this source code, and you can see here, uh, so I will open the source code, and you may see here this source code, uh, there is no template, so that is just a function of class, and the public that is defined is step 3, and this is the member functions. And what are the triangulation? Okay, here the triangulation value is here for 2, and the final element is 2, and also the degree of freedom is 2. So in this case we will have the solution or the result that will demonstrate for the 2D. So yeah, I have demonstrated, I have explained the code before, but in the here in the int main we can get the result like the step 3 Laplace problem. But yeah, we will just get the 2D result from that. But how about if we want to get 2D, 3D and 1D from one source code, from the same source code? And I will just uh, uh, re um, take I will just uh, keep the code, uh, and I will not change the code, but with the same code I will uh, get, yeah, I will run the two types of results, such as the code will provide us two, the solution for 2D and also the 3D. So for that case we want to apply the template. So yeah, I don't want to spoil the actual source code, so let's copy this folder here. So I'm copying this folder and pasting it here, and naming it maybe template 3, template 3, something like that. So let's get into this folder and open this folder, open this code. So I will not significantly change the code, or I will not change the degree of freedoms or the boundary conditions. I will make some changes that will affect the class and the function step 3 that will turns that will jump out from the class and get into the template, and we can get a numerous number of uh, results. So this is class step 3. So in this case I will apply the template here. So the template might be, yeah, I will apply the class template. So the I will write template, curly bracket, and int. So here you can give any type of name. So previously I have used T or any type of word, so I'm using my name here, int Asif. So where we will see this class step or this function, we will apply the template int Asif. So this function will get into that template, and the solution will be exerted from here. Actually the solutions, well, we will get into, this is the member function, and this is the triangulation, which is for 2 dimension. So I will keep it asif here and here. Okay, then here is an argument. So since there is an argument, uh, for starting this, before starting this argument, I will write the template here. Template int asif. Okay. Now, after writing the step 3, it was automatically defined for 2D. That was 2, and I will write asif here. Okay, so I'm just basically copy this one whenever I get this type of, yeah, say for example this void. So for this case I will type here asif and paste it here like that. Just copy this one. There are a lot of void, I think, yes, so I will paste it here. And keep in mind that if there are defined any type of triangulations or any type of notation, so we need to change that too. And here you can see the refined global, the mesh number, so I will not change that now. I will just focus on the template. So there seems nothing in the, if we scroll down, then we can get here another argument stars, and this Gauss quadrature. For Gauss quadrature I will get into this template so that the solutions, the Gauss quadrature analysis can be done into the template and get the provide the result. Also I'll type here for finite element analysis, and if there are any type of, okay, there's none, so I will scroll down here, and I think there are a limited number. Okay, this is the options where the equations are in the are put in the for loop. These are the I-axis, x-axis, which is analyzed by the Q index, and this is regarded as dx. So without wasting any time, we will scroll down. Here the zero function, so I will just write here my template name. Okay, this is clear, all clear maybe, and here too, and this one, this will extract the result. So this will solve, this is the solver section, and this is the data out. So the data out, the before extracting the data, all the data will be entered into the template, and then it will provide the answer just like the previous ones. Well, now this is the run portion, so I will just change here. I will make a condition here. um, since yeah, I will just extract the I want to extract the 2D and 3D uh, result. So I will write asif is equal to 2. So I'm giving it 2, and if it's 2, then it will print solution 2D btk file. If it's not 2, then yeah, then if it's 3, then it will be 3 is equal to 2, so it will not it's not true, so it will not print this one. So the compiler will go to the question mark. So if it's 3, then uh, it's not equal to 2. So since the compiler will go to the question mark, and it will print the next option. So how we can add the next option? I will just print it, copy it, and paste it here. So I'm giving it 3D. Now it's almost done. So this is the run options. So in the run section, we just need to write something for the output. So the std out will be solving problem in, and it will be my template name, and I will write space dimension, and also I'm sorry, also I have to close this one. So std endl and semicolon. So this is the same member function that was declared before, and this is the int main. So in the portion of int main, I want to print two results. So in this case, I will start a second bracket here, and a close bracket here. So here, when it comes to print the result, then I will write here this will be 2. So if the template name asif is equal to 2, then it will print Laplace problem 2D, and yeah, Laplace problem 2D. Okay, so for the case of 3, so yeah, in the previous case, if I wanted to without template, if I wanted to print 2D and 3D case, then I had to write the same code for the 2D, writing triangulation bracket 2, and then again write the whole code for 3D and write the triangulation, and into the bracket I have to put 3. And the problem is the code will be very long, and if there are any bug, then it will be very difficult to solve. So basically the code is almost the same, and I have put the main function into the template, and all the codes will be run into the template, and it will give the 2 results or 3 results that I want. So the here I want the 3D value, so I have write it here 3D. So I think it's almost done. Let's check it. Here something is missing, so I need to write here the same thing. I'm sorry. Copy, and here in the run portion I have to put this one. I think all are done. Let's check it. So it's done. The source code modification is done. Let's run this code. So let's open a terminal here. Let's see make for running. Hoping for the best. Make. So it is made. So the code has been run. That's beautiful. So instead here in the step 3, instead of getting one result from one code, we can get multiple results from just same code, and we can easily without changing the main code. And if there are some bugs, we can just edit the main code. We not need not to write all the code for the other results. Now I will run the executable file. So the program file is step 3. So I will write here. So here you can see solution 2D VTK, and the number of active cells are 124. That were these are the member functions. So the member functions, since the member functions were declared, depending on that member functions, it will the degree of freedom is like that, and cells are like that, like the same way of the previous results. So now you can see here for solving 2 space dimension, the answer is like that, and for 3 space dimension the answer is like that. So here you can see the solution 3D and solution 2D. Let's check my ls solution 2D and 3D. So this is not a visual file, so how can we visualize it? We can visualize it by maybe visit. We can go to visit, and we'll open the 2D file here. Okay, so I will make it pseudo color solution Android. So this is quite like that. It's beautiful, the solution of 2D. So I will make it a little bit fancy. Maybe let's set the mesh here, and since it doesn't need any elevation, so we don't need to set the elevation. So if I draw it, there are 256 since the refine was 5. And also if I set the contour, not necessarily, just for checking contour here, what about it? The contour is quite like that. Now I want to elevate this one, so how about elevating this? Just play with the options. If I elevate this 2D, one, then we will get this type of elevation. Okay, this is nice. So actually I don't want the axis here, so let's delete the axis. Annotation, no annotation. Then apply it, and now yeah, you can see here the elevated 2D shape. So this could be found by the uh, previous code. So how about we had also created the 3D? So why not testing other visualizing app like ParaView? Let's go to the ParaView and open the file here and get to the solution 3. This is the solution 3. If I apply it and just clear it, and here you can see the 3D. Before that we just get the 2D, so now we can also get the 3D here. So you may play with the 3D through like that. This is the contour, and if we just want to see this one, so also these are the edges here, and yeah, that's it. Maybe if we want to slice it, then we can get the clip here. So from this video we can get the multiple results from the C++ template, and I have demonstrated how to run it and what is the modified result, and also how to get the visualization with two software using VTK file. Thank you.